Welcome. Today we're going to demonstrate how to use Blue Sky Bio version 4.7 to design a single implant guide. We'll walk through the design, fabrication, and printing of that guide. First, go ahead and open the existing Blue Sky Bio file and we'll let it load. Once it is in there, we'll review a couple things. Usually I'll have my team go into the tools and redraw the curve to regenerate that focal trough and the panel. And you see we went up into tools, redraw curve. Once we're double click there, you can change the focal trough. You can move it forward and back. You can change the axial view there, as well as scroll around that curve to see individual slices. You can move the 3D model around, and wherever the cursors are, you can circle around that point on the panoramic curve. All right. Now, to start designing our guide, you'll notice you can click on different areas of that panoramic view to localize your view. You can also move the panoramic curve anterior, posteriorly, right and left. You can also widen it to help you see better or see less of the data you would like to focus on. So those are the basic general tools that you'll be using. At this point, you want to import your STL model. You'll go ahead and click on File, Import STL Model. Go find it wherever you've saved it and labeled it, and you'll tell the computer which jaw it is. In this case, we're doing the mandible. It'll try to correlate it on its own, which most of the time Blue Sky Bio does a pretty good job at correlating this STL file and the scan data. You'll see in the different windows the green outline will help demonstrate where that STL file has correlated within the CBCT scan. You'll notice in this case it didn't do the best job. So there's different ways you can manipulate that to line it up better. And you'll see on the right panel there, as we were observing to see how well it correlated. On the right panel, you can select different things to use to modify that correlation. In that case, we did points. The points, you will go and then on that the CBCT 3D generated model, pick some points, click on those on the teeth or markers, and try to correlate those within the STL file. Once you've done what you feel is sufficient number of points on each model, you will then click on OK, and the software will go through its algorithms again and see if it can better align the scan. And you'll see here as we do that, it takes a little bit of time, so just be patient. And once it does, you'll get to see kind of the similar view that you see there and reevaluate how well it did. I really like to use this axial view, and as you scroll up and down, you can see really quickly that it doesn't quite align perfectly. So we'll go to the manual manipulation, and you can start moving it around and centering it over those teeth. You can move it right and left, rotate it right and left, move it forward and backwards until you feel like it's pretty well aligned with the teeth. Once you feel like it's in the right orientation within that plane, you will shrink down that window and start evaluating it within the other views. That 3D view does a pretty good job of helping you see how well it's correlated. There's oftentimes distortion in that 3D rendering that doesn't give you the best view, but it tells you if you're significantly off in any direction or not. I like to look at that. You can turn that little panel off as well if you don't like that view. That would be within the, I believe, the tools panel or the edit panel. But in the 3D rendering, you can again move that model around using the arrows, which gives you a little better control. When you start just clicking on it and moving it, it really kind of messes it up pretty quickly. So by clicking on the arrows, you can do little movements. By clicking on the circles, you can also again do little movements. Going back to that axial view, you can see how well it correlates and see if there's any improvements. It looks pretty decent in this case, so we'll probably get back out of this view and start evaluating the cross sections or the rotational view. Sometimes it's hard to view that completely, but you can tell we're off a little bit. So we're going to play around, move it up and down and around. Again, going back to the axial view to see if it's improved at all. It looks like it's getting closer. Now we'll look at the cross-sectional view and scroll around that focal trough to see how well we've got that aligned. Looks like there needs to be some minor adjustments here. This is pretty critical that we get it as close as we possibly can, because ultimately the guide will be fabricated to fit on that model, which will tremendously affect where that implant is positioned, because if the guide or the model is positioned incorrectly in the CT scan, then obviously it will not be accurate when you seat that guide that was made from this model with the actual bone and teeth. Okay, so we're getting closer and closer here. We'll look through the axial probably again. You can look through the the rotational view again. You can keep playing with it till you get it just as ideal as possible. This is probably the longest part of planning a guide. Again, we're just checking in that cross-sectional view, see how close we are. It's looking really nice, especially immediately adjacent to the teeth that we will position the guide on. Again, going back and forth through that cross-section panel, everything's looking really nice. So at this point, you're probably going to feel pretty safe that your model is aligned properly within your CT scan, and you can move on. You can go ahead and turn off the 3D rendering. There you go. So now you're just left with your model. You can start designing where you'd like that tooth to go. I think it's really important that every implant is always planned with ultimately the tooth or the prosthetic in mind. So in this case, we're going to add a tooth. Select the tooth you'd like, the size, position it in the basic proximity of where you'd think it should be. Then I'd like to go to this 3D view and manipulate it in space, basically doing a virtual digital wax up, so that we can get as ideal as position, shape, form of that tooth as possible. Those purple cylinders, when stretched, will expand that tooth in mesial, distal, and buccolingual directions or dimensions. The arrows again move it in the direction of that arrow. The blue cylinder, when it's on, increases the vertical height of that tooth. So you can do that. There you go, and then position it to wherever you would like using the arrows. Again, I use the arrows because it gives me a little bit more control than just freehanding it. Same thing as we did earlier when we're trying to align the models very nicely. Those round lines will help you, or directors will help you rotate it into the right position. The arrows again will help you move in the right position, and the little cylinders will help you expand the tooth to the right size and shape. Once you're there, go ahead and lock it into place. And now you can use that tooth as a reference to exactly where you'd like that implant to be placed. We're going to remove that panoramic or that 3D radiographic view because it kind of gets in the way. You'll notice there the tooth's a little bit off position now, out of position. Rotate it to where you feel it's perfect. Lock it back down. You can change the model to whatever color you would like. There you go. And you are now ready to plan your implant. So planning the implant, you can go ahead and click on the button that says Add Implant, or that little implant icon with the plus sign, and select whatever implant you would like. In this particular example there, we're going to use Straumann, and you can kind of guess at which implant size you would want. You can also get back out of the plan and measure the bone to give you a better idea of the implant size and width, which we'll show you here in a second. In this case, we just clicked on the 4.8. We clicked on mandible to make sure it's in the right orientation. But here we will show you how to measure using the measuring tool. The width of that bone, you can see in this case, that's a pretty extremely good sized bone. And now you will feel pretty safe that whatever size implant you will choose there will be sufficient. So going back and adding the implant, we will demonstrate how to identify that nerve. You can go within the software and actually place a marker within that nerve canal, but in this case it's very visible. You don't need to go and mark it because it's visible in almost every view. And it's important to notice that as you plan an implant, you do not want to encroach upon that nerve. So now that we see where the nerve is, we've measured the bone, we can go back to the implant panel to add an implant. And we already know we need to click on the mandible. We wanted a Straumann implant, so we'll go back to Straumann. And the size, in this case, the biggest size possible would be fine. You can do a straight, tapered, whatever style you would like. I will say that Blue Sky Bio has some limitations. It doesn't have all the implant types in its library. So in this case, we're going to use a 4.8 by 14. And we just click where we'd like the implant to be positioned, and then you can use all the different panels there to help position the implant in the right location. Ideally, we want it to avoid any roots, nerves, and to exit the tooth right in the central groove of the design or planned tooth. We would also like it to have the right depth to allow proper emergence. In this case, there is a already vertical defect, so placing the implant flush with the top of the bone will be adequate. The other thing with an implant is you want to maximize how much bone is around it. You want minimally, if possible, 2 millimeters on the buccal and lingual of the implant, and the appropriate space in between the teeth. Usually placing it in the middle of the teeth is adequate. In this example, again, there's plenty of bone to place almost whatever size implant you would like. So now that we've designed it, we no longer need the tooth there. The tooth becomes an issue or in the way when we start designing the guide. So the implant's locked in place. We changed the settings of this software to advanced. We don't, in our office, use the drill stops, built-in drill stops, but you could turn them on if you understood all the parameters, which will help you control your depth and within your handpiece. So now everything's positioned where we'd like to. The guide cylinder icon is on, and you will program the cylinder or guide sleeve size and shape into the software. In this case, Straumann's traditional bone level tapered implant, the guide sleeve at its most outer diameter 6.3. Using the Formlabs printer, we add 0.02 to it to ensure that it fits nicely. the height of those guide sleeves are 5 millimeters. And now we have the position identified and planned for the guide sleeve within the guide. And we're evaluating to see how well that guide will be able to seat based on the tissue that's there. And it's perforating through the tissue, so we would likely need to raise it off the tissue. We do that with the offset. The offset measures the very top of that implant or the implant platform to the top of the implant guide. And you can see now moving it up 1 millimeter allowed us to exit the tissue. Really though, you can change that offset to whatever you'd like. In this case, let's just show you going down to 8 millimeters. It will bring it deeper within the tissue, which will likely be impossible to seat because the bone and the tissue will be in the way unless you remove the bone or tissue. So let's move it back to 10. We feel pretty safe there. You have to be very aware though of how far the patient can open. It's important to know or receive from the doctor you're working with, or as you're planning it yourself, that if you change that offset to an extreme or a bigger number, the guide length that you would need to actually appropriately drill that hole may not even fit back behind in their posterior mouth. So you just check the quality, the settings. You can modify those if you would like. I keep them pretty standard. You can change the guide thickness. Again, we keep ours at 3 just to minimize any flexure in the guide. Again, you can change some of the settings. You don't need to. Now you're ready to design the guide. So we're in the guide panel again. Everything's set and locked. We're on the right model. Make sure you are, or it won't let you design the guide. And you want to draw the curve. So holding down Shift, you'll just outline where you'd like that guide to extend. Usually on a single guide, you go 2 to 2.5 teeth on either side of the guide. Probably you don't have to do that much. And you just continue to outline the guide. And you want that to connect, so you have to push Shift and connect those dots. There you go. Now you can go into the edit mode. So going back to the guide panel, go in edit the curve by just pulling those little balls or cylinders or spheres to wherever you'd like them. Personally, you don't need to go all the way down on the gingiva. That's just a waste of material and it's not necessary. So bring that up just at the teeth. However you'd like to design that so it's nice and even and smooth, but gives you the rigidity and strength you need for a guide that will fit nicely and not bend or flex. So that's what we're doing here. Once you get it lined up, you can generate the guide. Before you do that, if you right-clicked anywhere that you feel you'd like to visualize the seating by putting a window in the guide, right-clicking will allow you to place a window. Again, same kind of principles of manipulation, rotation, expansion, movement, using the guides there, the circle lines as your tilting and angulation, the arrows as your movement, and the spheres as your expansion and contraction. Just be careful not to position it so far down on the guide that it will weaken the guide. You just want enough to be able to make sure it's seated. And so that's what we're evaluating here. When we feel we're good, we will create the guide. This takes a little bit of time, so you'll just have to sit and wait as it creates the guide. So as it calculates, it usually goes pretty quickly, slower at first, and then a little bit more quickly. Once it's done calculating, we will demonstrate how to export that guide so that you can print it. The exportation process does have a fee associated with it, so as you are ready to export, just evaluate that it's exactly the way you want and you're not exporting extra things, so that when you go to print your guide, it is exactly what you want. Unfortunately, I have done it incorrectly and had to reprint a guide, which that increased the cost significantly over time. So here we go, almost ready to finish our guide. Now in our office, once the guide is ready, before we export it, we will evaluate it and also create a drill report so that we can send that with our surgeon so that he has a quick view of where the implant's position and how the guide seats. So in order to do that, once you feel like the guide looks adequate and evaluate where you may need to trim or smooth, once it's done, you'll go on to the screenshots panel. You can also change the guide color if you'd like. You don't have to, but it just shows you that you can. Again, once you're ready to finish the guide fabrication, go ahead and click on screenshots. Once you've clicked on the screenshots, go ahead and click on drill report. You'll see the images that are automatically generated, which helps you see that when you're in surgery. And then click on the PDF. You can change any of the parameters that you'd like to add more detail or less detail. It's just the basic information that we click on for our surgeons. You can add the implant list, but because we customize the cylinder sizes and offset, we just don't click on that. We'll write that out, or we'll just know what it is. Once it's done, you'll save it into whatever location you desire. In our case, we save it to the patient's folder, and once it's saved there, that's ready to go. We'll usually open it right away and print it so that we can send it to our surgeon. In our office, we'll print that, put it with our case pan, and then it's ready to go once the guide is completed. All right, at this point, we are almost done. Now, what I'm looking at there is the offset. We will write out the implant length, the implant type, the implant length, the offset, and the key thickness to calculate the appropriate drill length. Okay, so we saved the file so that if anything happens, we're good to go still. Now we are going to export the data to print the guide. So click on File, we'll go to Export Data. Once we're there, this is critical. Uncheck all the boxes that you don't want to export in your file. If you don't, then you may print a little implant or a guide sleeve or the model as well. It'll all be connected in your mesh, which you just don't want. The guide will not work well. So once you have everything clicked, basically it's just the guide that you want to export. You'll click on Export. And save it to whatever destination you'd like. It reminds you that you will be charged for this. Again, once you've identified where you'd like to save it, you can label it however you'd like, so that you can easily identify it later when you're ready to print. Saves it as an STL file. Go ahead and export. It doesn't take very long to do that. And now we are ready to print the guide. So in this case, we use a Formlabs printer. So we will open the Formlabs printer or the preform software. select the correct printer. We have several in our office, and the right materials. Once we have identified that, then we'll open the file, locate where it is, and load it into the Formlabs software. In this case, we always rotate them so any of the surface that touches the tooth is not going to be in contact with any of the supports needed to print. We'll rotate it, orient it in the correct dimension. Again, rotate it so that the intaglio or the tooth contacting surface is not going to receive the supports. Once we have it in that position, we go and generate supports. At this point, you will want to evaluate where the supports are located and try to remove any of the support locations from the guide sleeve area. And you'll see here there's some on the platform of the guide sleeve. So we're just going to rotate the guide, click to generate new supports about in the same locations, and then click on the existing supports to remove them. And so the software is really neat. You saw how there's that little red area. It indicates that it's not supported adequately, so you can add supports until that redness goes away. And at this point, it looks like we're in good shape. No red, all thumbs up on the right side. Printability is good. So we're going to apply those changes, and now we're going to send it to the printer. First, just get in the habit of moving the location around so it maximizes the longevity of your tray. We're going to upload the job. It sends it to the printer. If you want to track it, you can. We usually don't. And now you're all ready. Thank you, and good luck making your guides.